Hello friends, 6.8. Yes, we're talking about as like analyzing graphs of polynomial functions. Probably one of the most favorite lessons in your chapter for you because all we do is use this. This is our best friend, we do it. Example 1. We're skipping the concept somewhere because they're telling you how to graph it by hand. We don't care, we're going to use the calculator. Example 1 says graph this function. I already put it in so you don't have to watch a video while I plug this in, and I'm going to do zoom 6 because I messed with my window many times. There's two things that I'm going to ask of you for sure whenever you graph this. There's only two things that I want you to do is find my exact zeros, and then you can wing it. And you already know what your zeros are without even looking at the graph. If I look at this function, I know that x equals 1 is a 0. Why? Because it will make this 0. And I know that x equals negative 2 is a 0 because negative 2 would make this 0, right? So when I graph it, when you're going to graph it home, I know that my graph comes through here and my graph goes through there. At this point, nothing else matters to me. So at this point, I can just wing it. I can come, boom, look at it, what it does. And actually it turns right here, right? And it goes back up. I don't care what that number is for now. I don't care what that number is for now. I just need you to go ahead and plot it in and tell me what it is. Okay? That's really all I care about. If you want to go an extra step, you can find your y-intercept by making your x 0, which would make this 1 over 4 times 2 times a negative 1 squared, or 1 over 4 times 2 times 1, which is 1/2. And you can even put that 1/2 is my y-intercept if you need to. I don't need you to do that unless you really want to have an exact graph. Now, that's how we graph them. I'm not going to spend more than 2 minutes on showing how to graph it. You go to what equal, you make sure you introduce it correctly. Always do zoom 6 because that would reset your screen on your calculator to where you can see your function. Please get out the 2 zeros, which really you can get them out from there easily instead of having to zoom in and make sure you get the right numbers. If you just look at your parentheses. Equal this to 0, equals that to 0. Those are your 2 zeros, right? Now, when you look at this graph, I want you to notice something. This graph goes up, and it kind of touches a top, and then it goes down, and then it kind of reaches a minimum, and then it goes back up, and it never stops. We call this a local maximum, and we call this one a local minimum. Okay? That's the highest point that a graph reaches that you can actually determine. That's going to be a local maximum. The lowest place a graph reaches that you can actually read, it's called a local minimum. And that's what you're going to do in example 2. Once we learn those turning points, why they're called, they're going to want you to tell me which one is your local maximum, which one is your local minimum. Believe it or not, that's why we love this subchapter. The calculator does all of this work for us. Let's try one. For example 2, we're looking at 374 as a page. F of x equals x to the third minus 3x to the second plus 2. Unfortunately, clearly I had the other function in. I don't have the other function here, so you're going to have to watch me do this. X to the third minus 3x to the second plus 2. Zoom 6. There's my graph. Okay, I need to know what is my local maximum and what is my local minimum. Believe it or not, we can graph this and wing it because we don't have perfect solutions other than one of them, which tells me x equals 1 right there, right? If I want to find my zeros, I can go ahead and find those easily. So here's my little graph. Every time they're going to ask you to do this, they're also going to ask you to graph, right? So I'm looking at this, I'm going, this goes through close to negative 1. It definitely goes through 1, and it goes back up at about 3. Am I correctly looking at that? I'm not sure. And it has a high over there that I know what it is. So my graph goes kind of like this, comes down, and goes up, right? I just copied this graph onto my board. I want to know what is my local maximum, what is my local minimum. By now you should be familiar with second calc. If you look at that, look at number 3. It tells me, find me my minimum. So I'm going to hit enter. And every time we do this, they're going to ask you, what is your left bound? What is your right bound? I'm looking for my minimum. My minimum is there, right? This is the lowest point that I can read. So I want to get this as close as I can to it on the left side. It's right there. Then I hit enter. Remember, when we do minimum and maximum, we only use left and right. We do not use up and down. And now I'm going to go back and give it the right boundary, which is right on the right side of it. I'm going to hit enter. And I'm going to say, please guess this for me. My minimum is x equals 2 when y is negative 2. So my min is 2 and negative 2, right? I just write it down. I do the same thing for my local maximum. I'm going to go second calc. My option 4 is maximum. I'm going to hit enter. And again, they're going to ask you, what is your left bound? My maximum is right there, so I need to get my arrow to the left of that maximum. There it is. It's right there. I hit enter. Now I'm going to use this arrow and move it to the right of that maximum. I'm going to hit enter. They're going to say, do you want me to guess? Yes, I do. My maximum is not a necessarily pretty number. It's at about, my maximum is at about negative 1.3 when my y is 2, right? I just went ahead and rounded up. The book makes it negative 1. What? Oh no, never mind. Oh, this is 0. That's a crazy number. This is my maximum is a 0 too. Negative 1.2 times e to the negative 6. Do you see that? That makes it a 0. We did this in class. I forgot. I was so confused. So my maximum was 0, 2. My minimum was 2 and negative 2. So again, second calc, option 3 will give you your minimum. Option 4 will give you your maximum. Remember, you're going to have to go to the left. Hit enter, move it with the arrow to the right, move enter, and then let it do the work for you, and you will guess it. Okay? The last thing we're going to do this here is your word problem. Believe it or not, we're going to use a calculator again. I'm pretty sure about that part. We're talking about an open box. We want to find out all of the volume of that. The volume for a prism is length times width times height. Okay, we know this. We have it in that common formula sheet. When you look at what you know about your box, you know that your width is 10 inches minus where you fold it. So my width is 10 minus 2x. My length is 15 minus 2x, because that's when we fold the box. And my height is x, because that's when we fold the box, right? That, whenever you put the box up, whatever that is, that's your x. So my volume can be written as 10 minus 2x times 15 minus 2x times x. Here's the great news about this, and we looked at this in class. We do not have to open that. We can plug that exactly into y equals. I'm going to clear it out. Parenthesis 10 minus 2x, close parenthesis, open parenthesis, 15 minus 2x, close parenthesis, and then open parenthesis, x, close parenthesis. This is our box. We don't have to do the math. Should I make you do it? Probably, because we do polynomials. I'm not going to. But this is a real life situation. So I'm going to go to my window. I'm going to make my x minimum definitely 0. My x maximum, I don't know what it's going to be. I'm trying to figure out what that would be. And I have no clue. I'm just going to leave it 10. I'm going to go by 1. My y minimum, I'm going to make it negative 3. Only for one reason. I want to be able to see where it switches and if it goes under. Okay? I don't know if it goes or it doesn't go under. So I'm going to go ahead and do that. And again, we're playing with this, okay? When you look at these volumes and you look at the numbers, you should know my y is going to be big. I'm going to make my y about 200 because I'm not sure how this is going to go, okay? And now let's go ahead and see what we get here. I'm going to do a graph. I get a local minimum. I can't see my local. I get a local maximum. I can't see my local minimum, which means I have to go to my window. And I need my y minimum bigger. I'm going to make it minus, I don't know, 20. And let me graph again and see if I can see my local minimum. I still can't see my local minimum. Do I care about local minimums? No, I don't. Never mind. Why do I not care? That would be a negative value. Can we have a box of negative values? No. We want to see just the maximum, right? In this case, we only care about the right, the positive values. So, second calc. I'm going to go to number 4. I want to find my maximum, hit enter. They're going to ask me, what is your left bound? So I'm going to have to move my little star using my left arrow as soon as it gets on to the left or of that vertex, right? As soon as it got to the left of it, I go, that's what I'm looking for. And then I'm going to say, what is your right bound? I'm going to move it all the way to the right of it. I'm going to hit enter, and they're going to say, do you want me to guess that? And we say, yes, we do. X equals 1 point, it's 2 if I have to go ahead and round it. X equals 2 and Y equals 132. Okay, which means the dimensions of the box are going to be, height is 2, length is 15 minus 4, 11, width is 10 minus 4, 6, right? So the right dimensions for the largest volume for the box, the largest volume is going to be 132. When my X is 2, all I have to do is plug my X in here and get the values for the dimensions of that box. Again, remember, the great news about word problems is we don't care about negative values. I should have stuck with the positive when I started. We just care for the real positive numbers. We deal with real numbers. And in this case, we needed to find the maximum. Quick review, second cock, option 4. You're going to move your little dot with your left arrow until you get to the left, and then with your right arrow to get to the right. Hit enter for it to guess it, and he will tell you the value. And that's about all we did in 6.8. For once, this is a short video. Happy homework.